Hi everyone, welcome to my talk. Thank you for coming, especially because it was the last session on the data track. My name is Monica Sarbu, and I'm working for Elastic, the company behind Elasticsearch, Kibana, and Logstash. I'm team lead at the Bits team, and today I will talk about how you can monitor your containers using the Elastic Stack. So what is Elastic Stack? Elastic Stack is a suite of open source projects. From the bottom to up, it's Logstash and Bits on the Ingest side. That is basically they are collecting data from the network and pushing the data to Elasticsearch, which is a search engine where you can store and do analytics of your data. And then you have Kibana, which is a UI with which you can visualize the data. And in this talk, I will concentrate more on the Bits. So Bits are lightweight shippers that install as an agent on your servers. They collect all kinds of operational data, and they are sending it to Elasticsearch. Nowadays, it's common, usually first you start with collecting the logs from different servers, and then you get interested in in monitoring the processes that are running on a container. So you end up having in Elasticsearch a diversity of data, and even if it's a structured or unstructured from different sources. So in the world of microservices and containers, where you would like to have a central point where you collect data, operational data from all your services, right? And so you can do a search across them, and also you can do analytics with them. So the Bits consists of a suite of lightweight shippers, and we have one for each data type. For example, we have FileBit for log files, we have Metricbeat for metrics, we have PacketBit for network data, and WinLogBit for Windows event logs. And if none of these bits that we created doesn't get the data that you need, that you can create your own bit by using the Bits platform. And the proof is that more than 40 bits are already created by the community. Yeah, so let's start with FileBit because logging is the most popular use case. So FileBit is a log shipper. The way it works is it tells the log files and then pushes them to Elasticsearch without parsing them. It guarantees that each log line is sent at least once to Elasticsearch, and it does that because it handles back pressure. It has support for features like multi-line. Think of these big Java exceptions that are on multiple lines. It has support for JSON logs. Think of structured logging. And also it has filtering support. For example, you might be interested in collecting only the error messages, the error log lines, and throw away all the debug logs that you have. Right? Parsing is difficult because each application can have its own format in printing the logs. And in order to be able to parse your log lines, then you need to kind of write grok patterns. And in with Elasticsearch, there are two options to do that. One option is by using the Ingest Node, which is basically a plugin for Elasticsearch. And the second option is by using Logstash. Back pressure handling, I think, is the most important feature that FileBit has, and I would like to take some time to explain it why. So in a common deployment, you will have a bunch of bits and only a few Logstashes. In this case, there are 3 Logstashes. And on each bit, you have to configure all the Logstashes. In this case, there are 3 Logstashes. And the bit will randomly choose one Logstash instance, and it will send all the data to that specific Logstash. And if the Logstash instance dies, then it chooses randomly another one, and it sends the data to that one. So the way it works is that Firebit reads a bunch of log lines, then it sends them to Logstash, then waits for ACK, and only when it receives the ACK back from Logstash, then it marks the log lines, the batch of log lines that you read as acknowledged, and writes offset into a registry file. And the offset is until when it read the log lines. In order to make sure that the offset is written on disk, then it does an fsync, and after that it starts reading again another bunch of log lines. So what this means is that Firebit is able to adjust its speed depending on how fast the next stage can process the log lines. But this also comes with you have to make sure that when you are doing benchmarking to keep in mind this thing, because, for example, if you have a single bit and a single Logstash, that might be slow if you are using the default configuration file. When the next stage is down, in our example is Logstash, for example, then Firebit partially waits, doesn't read any logs, so it doesn't lose any log lines. It doesn't allocate memory, it doesn't buffer things on disk, so it basically waits. Yeah, so let's see how we can use Firebit to collect logs from the containers. And if we are looking to the Docker login drivers, there are a bunch of options. And if we are looking closer, we will see that there is no login driver for Logstash and for Elastic Stack in general. We initially wanted to create one, but we soon decided that we realized that we won't be able to create, to guarantee that each log line is sent at least once. That will mean that we'll complicate quite a lot the login driver because we need to implement the back pressure handling. Another reason for that is that it was already a Guelph driver supported that you can use in addition with Logstash Guelph input. The advantage of this solution is that there is no shipper to install. You just send the log lines directly to Logstash. But the disadvantage is that this is UDP based, so you have no guarantees that your log lines are delivered, or there is no congestion control. Another solution is to use a JSON driver from Docker and use Firebit with the JSON support. And this solution is simple because JSON driver is a default driver in Docker, and it's also easy to get container metadata from your container. For example, the name of the container, the labels of the container. In addition, you can also get this Docker logs command that you can use on Docker. The disadvantage is that some people think that the JSON driver might slow down your Docker container. Another solution is that you can use the Docker syslog driver, and you need for that in parallel a local syslog server, and you might use Firebit for shipping. The advantage is that you will have a dedicated path with all your logs, and you get for free the facility of rotate your logs. But the disadvantage is that you have to manage another server, the syslog server. The metadata are serialized, so you have to deserialize the metadata information. And in case of multi-line, it's kind of difficult because you have the data from different containers mixed. Another solution is that you can use a Docker journalD driver and then Firebit for shipping. JournalD is often already available, so it's convenient. Another advantage is that you can get easily container metadata, and the Docker logs command works out of the box. The disadvantage is that FileBit doesn't support journald. Another solution, another option will be to mount a share folder from your host into the container and then instruct your application to write the logs in their share folder. This might be a simple solution if your application doesn't rotate the log files. If your application supports rotating your files, supports rotating the log files. The disadvantage is that there is no way how you can pass container metadata. Yeah, so as you see, there are quite many options how you can get container logs, logs from your containers. JSON driver, syslog driver, and share volumes are really good solution nowadays, right now. And in the future, we might also be an option to use journald when FileBit will have support for that. Actually, right now, there is a community bit that has support for journald, so we might also consider that using. So Metricbeat is a way how you can get the metrics from your services and also your containers. This is the newest edition of the bit. It's available in 5.0, which was released like 2 or 3 weeks ago. And the way it works is that it periodically interrogates external services, fetches metrics from them, and then pushes them to Elasticsearch. And has support for a bunch of services like Apache, Nginx, MongoDB, MySQL, PostgreSQL, Redis, Zookeeper, Apache Zookeeper. And you can here add your own module. So each service is written. The implementation of each server is written as a module in Metricbeat, and you can easily write your own service by adding a new module in Metricbeat. Adding a new module in Metricbeat is really easy. We even have a generator that generates the code for you. Metricbeat also has the system module, which gives you system statistics about your host. For example, it gives you CPU usage, memory usage, disk I/O information, file system, load, network, per process information, and per CPU cores. But let's see how we can use Metricbeat to collect the container metrics. And there are 2 options. One of them is to get the container metrics by querying the Docker API. This solution is not yet released, but it's available in the Docker module of Metricbeat, so you are free to use it. By querying the Docker API, you can get information about the CPU, the memory, you can get the Docker container information, you can get information about an overview of your containers, like how many containers are stopped, how many containers are running. You can get network information like inbound and outbound bytes, drop packets, a disk I/O, things like this. This solution is easy to set up. You don't have to do basically anything. It's come out of the box. And you also have access to the container names and labels. Another solution is to get a container matrix is by reading cgroup information directly from /proc. The advantage of this solution is that it's working for all kinds of container technology you are having, not only for Docker, right? And the implementation of this, it's part of the system module, and if you are enabled in the configuration file of Metricbeat cgroups, then you will be able to, you will get automatically enhance the process information with details about the cgroups. The disadvantage of this solution is that you don't get container metadata, like name of the container and labels. No matter what technology, no matter what solution you are using, you will probably want to run Metricbeat in a container on your host in order to be able to monitor all your services that are running, all your containers, basically. Often when I'm describing Metricbeat, the objection that I get is that Elasticsearch is not meant to be a time series database. Because people think of Elasticsearch as a search engine, and it's not so efficient for storing numbers. But actually, this is not really true. Elasticsearch and Lucene, the project on which it's based, they have support for numbers for quite a long time. And it's got even better with Elasticsearch 5.0 when they introduced a new storage system based on BKD trees. So BKD trees were introduced because it has support for multiple dimensions. Think of GeoIP points where you have a dimension is longitude and the other one is latitude. But it proved to be that it's quite efficient also for a single dimension values. Think of integers, right? And it seems that with 5.0, it's Elasticsearch is faster to index, it's faster to query, it has more disk efficient, it's more memory efficient. Another disadvantage that Elasticsearch had pure 5.0 was that it wasn't able to compress the flow values. And they were always stored on 4 bytes. So there are quite many algorithms for compressing the flow values, but they are not working with the way Lucene is storing the data. So we couldn't use them. So in order to offer a workaround for this problem, in 5.0 there were 2 types of flows introduced. One of them is half flows, that is storing a flow value on 2 bytes. And of course, you have good precision for small values, and the precision degrades with the bigger number it is. Another type is scale floats. The idea is to be able to store a flow value as an integer using a scaling factor. For example, if you have a scaling factor of 100, you multiply your flow value with a scaling factor, and the result you store it as an integer in Elasticsearch. And when you query Elasticsearch, then Elasticsearch will divide the value with 100, and then you'll get back the flow value. This is a great way how you can store percentages. Think of CPU usage, right, for example. So why Elasticsearch for time series? Because it has horizontal scalability, it has the mature support for clustering, it offers these flexible aggregations, including moving averages or hold winters that are used in anomaly detection. It's a system, it offers a system that where you can store not only logs, but also metrics. It offers a wide range of UIs, and it's a great ecosystem. It also comes with alerting tools, reporting, and so on. And not least, I would like to talk about Packetbeat. So Packetbeat is for network data. So the way Packetbeat works is like you install it as an agent on your server. It's listening for the traffic exchange between your services. It decodes the upper layer protocols, correlates the request to the response to transactions, and then push them to Elasticsearch. And we have a support for a few decoders, like HTTP, Thrift, MongoDB, MySQL, PostgreSQL, Redis, and so on, right? And if you want to add a new one, you can create also your own module in Packetbeat to have support for a new decoder. In case you have the traffic exchange between your services encrypted, or in case there is no decoder for that traffic, you can still have visibility into your traffic by using flows. So flows will give you a few details about your traffic, like the source and the destination, the number of packets exchanged between the sources and destination, and also the number of bytes, and a few other details. Yeah, let's see how we can use Packetbeat to monitor the traffic exchange between your containers. So it's very simple. You just need to have Packetbeat installed in a container on your host, and then it will be able to show you the traffic that is exchanged between your containers. And now I would like to do a short demo. So what I have Elasticsearch and Kibana running on my Mac. And I have an Ubuntu machine where I installed Filebeat, Metricbeat, and Packetbeat. It's very easy to install, so that's why I didn't want to go through these steps. So just go to the download page, download the version that you want, like in my case, the deb package, and just install it, and that's it. And I also like to run a small Docker containers that with Redis. As you can see, can you see my cursor? Probably not. So as you can see, I also passed some container metadata to this container. And after we start the Docker container with Redis, then then Docker will write the log files into a special directory under var lib docker containers. And if we see, we have a directory for each of the containers that we have it running. So let me show you, maybe some of you are already familiar with this. Yeah, so this is how it looks, the log file that is written by Docker. As you can see, it's in a JSON format, and as you can see, the log field basically contains the log line. Now the idea is to instruct or to configure Filebeat to read the log files from that directory. So basically, I configure a prospector in Filebeat, and I pass here all the JSON log files from that directory. And also I mentioned here from where to get the field name from the JSON object, from where to get the log line. This is useful in case you want to configure multi-line. Okay, now let's go to Kibana onto the discovery page. So after we restart Filebeat with that configuration file, Filebeat will send the data to a specific index in Filebeat called Filebeat. So we'll be able to see the log lines. Actually, there is no log lines, so let me restart the container so I can produce some log lines. And now if we go back, there should be some here. Yeah, as you can see. So we will be able to see exactly all the fields that are part of this JSON object that Docker writes. And also in JSON.log is basically the log line. Let me show you how you can get the metrics from the container. So for that, we can configure Metricbeat. Oh. And here we configure to have the module, the system module, which gets the system statistics about your host, like the CPU load, file system statistics, network, memory, and so on. And also you can configure here how often to fetch this information from your host. Another module that is interesting, I think, in this scenario is to configure the Redis module, because we have started a container with Redis, And here we can specify what kind of information we want to get about the Redis service and how often to query the Redis service. And of course, where the Redis service is available. Another module that might be interested is Docker, in order to get Docker containers, information about the Docker containers, and here we can specify what information we are interested in. And you can see here the host is basically where the Docker is available, and optionally we can also specify the socket. Is it too small? Yeah. So if we start Metricbeat with this configuration file, then Metricbeat will send the data into this into the Metricbeat index pattern. And if we switch in Kibana the index pattern to Metricbeat, then we'll be able to see all the metrics information, because there are quite many. Let's see first all the system statistics related metrics, and for example, we can see the network statistics. So for example, we can see here how many packets are inbound, outbound, how many are dropped, and things like this, right? Now let's also see the CPU usage as an example. So we can see the CPU usage in percentage, in kernel space, in user space. And for example, the processes that are running on your server. So for each process, you will get an event. So for example, in this case, for this process, you will get like the memory usage, the CPU usage, the PID, the state of the process, things like this. So now let's go to Redis. Basically to get all the metrics related from the Redis service. And as you can see here, there are quite a bunch of information that you can get from Redis. Yeah, and the list goes on. And now let's see what information can we get from the Docker container. And for example, we can get information about all the Docker containers that we are running on the host. For example, we can get how many are running, how many are stopped, and yeah. And interesting is that for each metric, you get the round trip time. So you know how much Metricbeat spent in getting the information about that specific metric. Let me also show you quickly the container information, just to give you an idea. So you see here that you are able to see the container metadata that I passed when I started the Redis container. And besides that, you can see all kinds of, for example, you can see here the image, you can see the container ID, and you can see, when I started the Redis containers and things like this. Yeah, we can also see the CPU usage. So basically, all this information that I'm showing you about the Docker container are as a result of querying the Docker API. And as you can see, I didn't have to configure anything special for that. It was just out of the box, right? And this is because the JSON driver is enabled by default in Docker. Yeah, so I was showing you the CPU usage, and you can see here I can get the CPU usage of that Docker container. And the Unix socket that is used, yeah, things like this. Okay, now I would like to also show you how you can get information about the traffic exchange between your containers with Packetbeat. And for that, let's go to the configuration file of Packetbeat. So the most important configuration file is the interface where it's listening for the traffic. And we can use the default one. And for each protocol that Packetbeat supports, you can configure the port where to listen for that specific traffic. So yeah, we are not changing anything in the configuration file. And if we start Packetbeat, then Packetbeat will send all the traffic information to Elasticsearch and store it in this in the specially indexed Packetbeat index pattern. So if we are choosing here the Packetbeat index pattern, then I should be able to see all the traffic. Just to give you a quick demo, let's generate some Redis command, and then let's quickly check it. So this basically are all the transactions that are exchanged in our network. I mean, I only have one container, but should be enough. And as you can see here, I can see the query that I just sent. So each bit is coming with sample dashboards that you can use as a starting point for your own dashboards. And if we go to the dashboards, then, for example, I created this sample dashboards to show you all the processes that are running on your host. And for example, here at the bottom of the page, yeah, everyone likes graphs. For example, here, let's start with graphs. So for example, here, like you can see the CPU usage per process or the memory usage per process. Also, I would like to show you that here, this table basically, it's the result is similar with what the top command looks like in Linux system, Unix systems. You can see for each process how much memory, how much CPU usage has. And you can order them. Here they are ordered by memory usage, and in the other one are ordered by CPU usage. Another interesting dashboard that I would like to show you is the one about Docker. So you can see the containers that I'm running, and yeah, details about each container that I'm running, details about the network I/O in nice graphs that Kibana creates. Yeah, I think that's all. Let's go back to the slides. Let me quickly check how much time I have. Okay, so that's all. Thank you for your attention. If you have questions about bits, don't hesitate to contact us on our forum at discuss.elastic.co. If we have feature requests or ideas for features, don't hesitate to create an issue in our GitHub repository. Thank you very much. Now, if you have questions.
It's about, you mentioned the scaled flows. How do you handle rounding with these scaled floats? Because so when you have a scale of 10 or something, then you have a rounding in the or are they stored as Oh, so
They are stored as integers. So
And-
you will have a precision of, for example, if you have a scaling factor of 100, then you will have a precision of 100, of 2.
And so basically, I send them because I send them to Elasticsearch as a string usually. In the JSON format, when I send them to Elasticsearch to insert them, I send them as a string, and then they are converted basically into an integer.
So the way it works is with Elasticsearch is that you define a mapping in advance, and you define what kind of type each field is before inserting for the first time in Elasticsearch. Elasticsearch is also doing a good job in detecting the type of each field, but not always work. For example, if you have an integer and if you have a float and sometimes for some reason the first time when you send the value of the field to Elasticsearch is 0, then Elasticsearch will detect it that it's an integer. And then when you send the next value, which will probably be a float, then Elasticsearch will think, yeah, I'm expecting an integer, not a float. That's why it's recommended to set the mapping in advance before sending, for each field, before sending the data to Elasticsearch for the first time.
I was just only confused by the name float, because when it's always stored as an integer, it's like more a fixed decimal instead of a float. Because there is no floating point, the point is fixed. Is this correct?
Yeah. It's stored as an integer, but it's a float basically. It's just that you store it. So let me say again. So a scale float is basically a float that you store it as an integer using this scaling factor. So for example, if you have a scaling factor of 100, then you multiply the float value with 100, and the result you store it as an integer.
But it's not in the float in the sense of that it's a binary float where you have, like in RFC, I don't know the number, float with a binary where the digits behind the dot are stored as binary fractions.
Yeah. Other questions?
I read about where's the source for it? Is it identical to Docbeat and Git project?
Yeah, so Docbeat is a community bit, and now it's part of Metricbeat, so it's a Docker module in Metricbeat. It was the ones that created Docbeat kind of moved the code from Docbeat, and now it's part of Dockerbeat.
So
Metricbeat, sorry.
So
it's a Docker
open
module.
Source or is it?
Yes.
Okay.
Yeah.
Thanks.
It's not yet released, but will be released in the next release.
There were two questions. I think they have the first one you have answered. It was asked very early.
Yeah. So the question is Filebit okay for sending application logs from Docker containers? If yes, when it's better than Logstash? Yeah, that's a good question. So the first question that's why I had a talk. So to give you a few options or a few solutions how you can get the logs from the containers, and you should decide by yourself which solution fits you the best. And when it's better than Logstash, that's a tricky question. So it also depends on your infrastructure. So you can also use, for example, Logstash. You can use, like I said in the presentation, you can use the Guelph driver from Docker with the Logstash Gelf plugin, input plugin, in order to get the logs. But there are a few disadvantages of the solution, like I presented. So it depends what is more important for you in order to choose one solution or another. By the way, if you can, I will tweet, after I finish the talk, I will tweet the location of my slides, so you will be able to see all the options that I presented about how you can get the logs from the container. And then you can decide, it's up to you to decide which solution is the best. What about fluentd drivers that send logs to Elasticsearch? I think here it's more a question for fluentd guys than for me. So, like I said, there are a few login drivers, but none of them solve this problem of guaranteeing that each log line is sent only once. And this is what we are trying to achieve here. So other login drivers, for example, they are sending the log lines as fast as possible, and if the next point in your network doesn't cope with that amount of traffic, it can die, or it can start behaving strange. So we were trying to find a solution with this by adding support for handling back pressure in order to for Firebit to adjust the speed depending on how much the or how fast the next point in your infrastructure can process the data. About what? Sorry, I didn't get about.
About the throttling of the logging output. So when you have this incident situation, when you don't have a consumer for your logging or the node is dead, the new logging that is coming, is it being copied and duplicated on disk, or do you set some sort of marker to resume from that point on, outputting and flushing the data to the node?
So for that we have the registry file where we keep an offset until when we read the log files.
So this is the marker strategy then? You don't duplicate it and wait for output?
We are also, I'm not sure I understand when you mean wait for output.
When you store the logging data that is coming and cannot be outputted to the consumer, so you just set a marker in your log and you resume from that point on instead of storing somewhere else that the new data that is coming. That's my question.
Yeah, we are not storing somewhere else.
Okay, that's
we are restoring.
You just set a marker and then play from that point on instead of copying the data, yeah?
Yeah.
Okay, thanks.
I hope I answered the right. I'm not 100% sure about this, but I hope I answered the right question, the right thing.
Okay, no more questions. Thank you, Gary.
Thank you very much.